All right. Well, hello, Dr. Neilsen Gammon. Thank you for taking the time to join us today.
You're welcome. Good to be here.
Yeah, we're happy to have you. Let's just start out with you telling us a little bit about yourself and your work both as the Texas State climatologist and in the Department of Atmospheric Sciences there at A&M University.
Sure. Well, I grew up in Northern California, went to college in Massachusetts, and I've been at A&M for the past 32 years or so. My original focus was on weather and weather prediction. I got involved in uh, climate because we were trying to get a automated weather station network across the state of Texas, much like Oklahoma has had for uh, at least as long. And that was run out of the Oakland Climate Survey. And when our state climatologist from A&M retired, I was the only one who actually wanted the job. So I got appointed that. And I've gradually become a climatologist after having attained the title of that. So now I do, I do research on climate extremes that affect people in Texas, things like droughts and floods and extreme cold. It's one thing after another, apparently. And I'm also now the director of the Southern Regional Climate Center, which covers every place from Texas to Tennessee. And so we're expanding our operations to provide climate services to a broader area. So that's been interesting recently. But in the meantime, um, just basically helping people in the state of Texas make the best possible use of weather and climate information.
Yeah, well, that's exciting and certainly timely work right now to be a climatologist.
Yeah. When I started, climate change wasn't a thing. It was more ordinary climate survey explaining what El Nino and La Nina are, and that's still a big part of it. But suddenly, a lot of people are interested in it.
You had no idea what you're getting into, huh?
Not really, no. Especially not when our governor was running for president at the same time we were having our 2011 drought, and he was getting all these questions about climate change and so forth, and I had to be out there saying how much of that was climate change, how much of it wasn't.
Wow. Yeah. Well, that's interesting. You were the expert. It's probably good to have you there answering those questions. It'd be complicated because and a lot of us it's hard to imagine like what exactly goes into climate change research. So I know myself and the public often we think of temperature and rainfall and weather variables, current trends, but how does one actually study climate change? Because I think this is a hard one for people to get their minds around.
Yeah, I think well, I mean, of course we have observations, not just the graph that people see of temperature going up, but we've got things like um, observations that consist of what are called Argo floats in the ocean that float around about 2,000 feet below the surface, and every 2 weeks or so they come up for air, or actually a hit of sunlight for their photovoltaics, and they record the temperature and transmit the information to satellite while they're up on the surface. And that's an international project that's been around for just a couple of decades, but it wasn't until then that we actually had measurements of the Earth's energy imbalance. Climate change is driven by the fact that we're receiving more energy from the sun than we're losing to space. And with that, we finally had actual measurements of that. Of course, a big part of climate research is also climate models. I don't think I don't think hardly anybody in the general public understands climate models, which is fair. They're quite complicated, but the way I describe them is they are they are simulations of a planet very much like our own, and it lets us do experiments so it can test things, and the results translate to the real world if you're a little bit careful about it, but it's not an either or proposition. They're not fictional and they're not reality. But we can't do experiments on the real climate very easily, and we wouldn't
Right.
want to. So we use this as our laboratory tool.
Wow. I don't think anyone's ever put it like you just did
for me. I don't think I've ever understood climate change like the way you just said it. We're receiving more energy from the sun than we're losing to the atmosphere. Is that what you said?
Yeah.
Then we're losing to space.
Okay.
That I've never heard it put that
Thank
way
you.
either, but that
Yes,
makes
thank
so
you.
much sense. Could you dive into that a little bit? Like, could you talk about the process for why we aren't losing it to space and sort of
Sure.
dive into that part?
Yeah, I mean, the Earth is described as big blue marble, which is fair, and it's in a vacuum, so it's extremely well insulated. So the only way it gets energy is from the sun, and the only way it loses energy is by radiating energy out to space. Everything that's not at absolute zero actually radiates energy. If you're normally not aware of it, although, you know, when you're sitting in front of a fire, you feel the heat from the fire, and that's not the air temperature coming from the fire, because the fire is sucking air in and carrying it up. It's actually the radiant energy. Just like you can put your hand underneath a lit light bulb, you can feel the heat from that. So only when they have that big contrast we perceive it, but it's happening all the time. If you look at a satellite image on the nighttime newscast, that's an infrared image that's detecting what is being emitted from the Earth. Daytime, we get the illumination from the sun, we can see stuff, but at night, it's what's being emitted, and it gets color coded so that the objects that are cold are white, and the objects that are dark are are warm. Objects that are cold are white, objects that are warm are dark. Because clouds are high up, they're colder, and so they're emitting less. The hotter something is, the more energy it emits.
All right.
Okay, so that's key concept number one. In fact, you can actually see an infrared satellite image if you can't feel infrared heat most of the time. Concept number two, that fact that we can detect clouds because of how high up they are, and the higher they are, the colder they are, the less energy they emit. If we do something to the atmosphere that makes the air emit energy at a higher altitude, it'll emit less energy. And that's what greenhouse gases do. They, like, gases like carbon dioxide are emitting energy to space. You can't see them in a satellite image because the satellite image is actually tuned to a narrow range of wavelengths where that doesn't happen. But we've got satellites that can look at carbon dioxide emissions. We have satellites that can look at water vapor emissions. We have satellites that can look at methane emissions. And the more of that gas there is, the higher up whatever is able to escape to space is coming from, and it's lower intensity because it's higher and colder, so it's less energy. So that's the main imbalance. It's just as if the sun were dimmer, we're brighter, we get more coming in than we get out. As it is, the sun's about the same, but in a sense, the atmosphere is dimmer. It's emitting less energy, and so we're warming up. And as we warm up, we'll emit more energy, and climate's trying to get back to equilibrium. But if we keep changing the atmosphere, it's not going to reach equilibrium.
That is super interesting.
Yeah.
I will admit that I don't know much about the inner workings of climate change. I know the general idea, and I've read a few papers, but the explanation was amazing. I have not actually heard that before, so I really appreciate that.
You're welcome.
And on the idea of like this warming as the main issue that we mostly think about with climate change, it seems like a lot of your work is actually focused on variability in rainfall patterns, and that's probably really applicable to Texas specifically, where you mentioned that, there's drought season and, those drought events may be exacerbated. Could you tell us more about your work on the extreme rain events and droughts in Texas?
Sure. Yeah, with the extreme rain, we were interested in, what weather patterns cause it, and whether to be able to forecast it. And then with after Hurricane Harvey in particular, the key question became, well, how much is it changing? Because we design our infrastructure, if it's in a floodplain or not, it's like a bright line based on a 1% chance per year of getting flooded. Well, if heavy rainfall is becoming more frequent, then the line's in the wrong place. And so we'd have to deal with that in some way, it certainly would be of interest to the person living on the wrong side of the line.
Right.
And unfortunately, it means they might have to, if the line's updated, they have to buy flood insurance, the property values go down. And so it's an economic hit from increases of extreme rainfall, even if you don't get the flood.
Right.
So it happens that extreme rainfall is one of those things that's pretty well pinned down by climate change, at least in terms of the direction of the change. Warmer atmosphere can hold more water. And so if storm systems don't change, you'll get more intense rainfall. And if storm systems do change, then maybe it'll be even more intense, or less. It'll be some tweak to that tendency. We've done an analysis for Houston that basically says that, yep, heavy rainfall is increasing across all the southern United States. It's gone up by intensity's gone up by almost 15% over the past few decades, and which has increased the odds by close to a factor of 3 of event happening. But even that Harvey was so exceptional, we probably won't see it again. So right now we're working on similar analysis for the whole state of Texas to update it, because up to this point, what the federal government's come out with is just assumes that climate doesn't change, and that puts us basically behind the curve.
Right.
Drought is harder because, well, good luck defining drought in the first place. It's basically, it's sort of less water than you normally have, and it matters that you have less water. Some combination of that might be a definition of drought. But it turns out that the impact of climate change on drought depends upon what aspect you're looking at. For example, heavy rainfall. If rainfall becomes heavier, then more of it runs off and less of it soaks into the soil. So we see climate models consistently projecting a decrease in the amount of moisture in the soil across not just Texas, but basically all the United States. But on the other hand, with more water running off, that means more water going into reservoirs. And so surface water supplies potentially aren't impacted as much by climate change as agriculture and groundwater supplies.
Right.
And that's true even if rainfall doesn't change. We're not sure what the trend is going to be in Texas for rainfall overall. But if intensity changes, then you get this trade-off between surface water and groundwater. Of course, groundwater benefits by not losing to evaporation, whereas you're keeping water on the surface through a reservoir is constantly evaporating as well, and higher temperatures make that aspect worse also.
Wow, interesting. Could I ask you a question about the rainfall and the drought bit? You mentioned that, we're experiencing shifts in rainfall patterns, and you said something about, it depends on if storm systems change or if they don't. Could you elaborate what you mean by that? I'd not really thought about storm systems shifting with the climate, but it's clear from what you've been talking about that could be the case.
Yeah. Technically what we call it is for just the basic direct effect of temperature change, we call it the thermodynamic effect. It's a longer word than it needs to be. And then weather patterns themselves change. Call it the dynamic effect. And Hurricane Harvey is a good example of different things that can happen. So, for example, we don't know for sure whether the number of hurricanes is going to go up or go down. It'll probably go down. So that would make a Harvey rainfall less likely. But the maximum intensity of hurricanes is probably increasing. So that would, and that's part of what helped Harvey stay together while it was on land. So that might increase the chances of Harvey. We think that hurricanes develop a much stronger inner core of rainfall with climate change. So it would increase rainfall intensity from hurricanes because of the way the storm structure changes. And then Harvey was so bad because it slowed down. And so far, there's been 2 studies on how the speed of motion of hurricanes in the Texas area might change. And one of them says they'll speed up and one says they'll slow down. But obviously, it's going to make a difference one way or the other.
Right. Oh, that is really interesting.
It is. That's very interesting and a little bit well, I mean the whole thing is just uncertain, I suppose. So there's a little uncertainty no matter how you look at it, but I want to ask you about the impacts maybe that we might have already seen. We're really good at growing things here in Texas. We've got crops throughout much of the state, and then where we do generally get a whole lot of rainfall in the eastern part of the state, we've got even the bigger crops, the pines and the hardwoods, and these are very important parts of our economy. Have we already seen impacts to rainfall, whether it's drought or extreme rainfall events, uh, in agriculture? Have you already witnessed that?
Well, it depends on where you are in the state, actually, because over the past century in West Texas, rainfall really hasn't changed much in terms of overall amount. Whereas in East Texas, it's gone up by about 10%.
It's gone up.
Yeah.
Okay.
So, so it, basically the 1990s were like the wettest decade of all in general. And so, um, West Texas has seen, I think, a bigger negative impact from climate change because the higher temperatures mean that soil dries out faster. The rain they get doesn't last as long, and that's on top of rainfall becoming more intense when it does occur. So their agriculture is having, I think, a harder time of it because of that combination of factors. In East Texas, probably not so much. I mean, rainfall is generally favorable for
Mm.
agriculture, and the um, temperature increase hasn't been enough to essentially negate the increase of rainfall amounts. So as long as you're not getting too much rainfall and getting fields submerged, there hasn't, I don't think, been much of an effect on East Texas agriculture.
All right. Now, when you look at what you might consider the best models for the future or the best predictions for the future, are you able to make some projections about what might happen to agriculture and the forest industries in Texas in the future?
Yeah, we don't know which models are the best, but if if they all say the same thing, that it doesn't really matter. So you look at whether models are consistent in what they're projecting.
Okay, that makes
A-
sense.
And for temperature, for example, they're pretty consistent that if the globe goes up by a degree, Texas temperatures go up by about a degree and a quarter. It just stays proportional in that regard. For rainfall, they're a lot less consistent. They're all consistent pretty much in the sense that Mexico tends to get drier and the northern United States tends to get wetter in terms of amount of rainfall. And we're sort of in the middle somewhere where the average climate model says a slight decrease, maybe 0.5% per decade, which is less than the increase we've seen historically. So who knows what rainfall is going to do? So it's the temperature effect and the greater intensity and possible changes in the timing of rainfall during the year that's going to matter, I think. But, agriculture is so dependent on rainfall that the natural variability is still going to really control things, whether you're in a drought year or not. We're still going to have droughts, whether rainfall overall increases or decreases, because we've seen droughts throughout Texas history and before that as well. Um, the uh, the change in temperature can have an impact in terms of the viability of of cultivars and plants to survive drought, because droughts will last longer. So you have to go deal with the trade-off. More drought tolerant stuff means lower yields on average, but at least you get yields when you have a drought year, that sort of thing. Those are the sorts of calculations farmers are going to have to make.
Okay, that makes sense.
Yeah. What about the folks living in the cities that aren't as, particularly involved with agriculture, or they're not out on the farms, but they're city dwelling, what's climate change going to do for, water availability for cities, temperature, and these sort of thermal dynamics that happen in cities where you don't have as much green space?
Right. So, if we have the economic means, we can control our climate. We actually call it climate control, um, with air conditioning and heating and so forth.
Oh, yeah.
It's worth keeping in mind that's not true of everybody that lives either in the cities or in rural areas.
Yeah.
So that changes in climate have a much bigger impact on some segments of the population than others. But you're right. I've been talking about water in terms of water supply. Water demand is also going up with climate change because a large portion of urban water use is lawns, and they dry out faster, so you have to put water on them more frequently to keep them green. We've steadily seen improvements in my water use per person. That's been declining slowly, but the number of people in Texas have been going up faster than the water use per person has declined. So we're going to see increased stress on water systems for that reason. Fortunately, because so much of water is used to water lawns, that means that we can survive water issues by not watering lawns so much, which is not really a hardship for most people. So we have a lot of leeway in the system, whereas in a place like Las Vegas that is replacing all their lawns because they under normal circumstances don't really have enough water. There's not much more they'd be able to cut.
Right.
Yeah. I want to jump in here and ask about something that you just mentioned. You mentioned that if we have the means, we can control the climate. But not everybody has the means. We lose folks every year to extreme heat. And I guess in February 21, maybe over 200 folks died in Winter Storm Uri. Is this changing climate, is this going to even further segregate some folks who don't have the means to keep up with these climate issues? Is it going to hit some people more than others?
It will, because climate change is going to make some infrastructure more vulnerable, is going to make some places more vulnerable. But it's and I guess also generally those places have less political power, so there's less resources being directed toward them to uh, mitigate the effects of climate change. But it's not much different from the challenge that we have without climate change, just from extreme weather in general. People live in vulnerable locations not because they enjoy the risk, but because the land and housing is cheaper there, precisely because it's more vulnerable. And the alternative is not living someplace safer. The alternative is not having a place to live at all. So unfortunately, we're always going to have that vulnerability, and I think the best way society can deal with that, at least one important way, is to make sure that those places are at least resilient in terms of human life in the case of emergency, so that there's clear evacuation strategies for people who may not have the means to evacuate on their own. There's um, people who can come in after a disaster and help people find the resources that they need, because they generally don't know where to turn under that circumstance. If you're well off, you can figure it out, but you may not be able to figure it out if you're not.
Okay, that makes sense.
Yeah, especially useful in hurricane zones.
Mhm.
Yeah. So in Texas specifically, Do you have a sense for what our role as a state is in our carbon footprint or our contribution to climate change? We've got a lot of industry down here, oil, gas. I don't know if there's breakdown by states. We also have a lot of people, so I wondered if you had a sense for how Texas ranks as far as our contributions in this space.
Yeah, we're depends on how you tally up, really. I mean, we do have a relatively large share of carbon emissions, even on a per capita basis. That's um, that's because we have a outsized share of oil exploration, oil drilling, and refining, and so forth. Um, we're probably we're I don't think we're not. I was going to say we aren't in love with our cars at a notably greater extent than California is, but we are in love with our trucks more. The but we're feeding for the oil. We're feeding the needs of the nation essentially. Someone's got to do it.
Right.
If we're going to still be using gasoline and fossil fuels until replacements have become widespread and economically viable, and that transition has happened. So yeah, we are pretty big contributor. The turns out I think more energy is spent overall in heating in the United States than there is in cooling. So at least our hot summers aren't dragging our emissions down up as much as say the cold winters in New York might be.
Right. I turned my
Okay.
heat on for 2 days earlier this month, and my bill was like $100 more expensive for that. And I thought, never again. I'll just suffer the 58 degrees or whatever it was.
That's great. You need a fireplace.
I do.
Yeah. Well, if you could, along those lines, if you could give Texas a report card for how we're performing in conserving a healthy climate, what grade would you give us in different industries and areas of the state?
Oh, I don't know. I mean, the fact that we actually put in the infrastructure to permit widespread wind power generation through turbines was huge, I
Okay.
think, and it's been beneficial all around. We've actually gotten pretty close to the capacity for that, so we have
Really?
to. It's time to make another major investment like that to allow wind power to continue expanding. Um, most most industries try to look as good as possible in terms of climate change, whereas it's only to the extent that it's helping the bottom line. And that's just the way the incentives in business work. So um, there aren't a whole lot of industries that are, um, other than the ones that are focused on renewables, that are really doing a lot in terms of reducing climate change. Um, and at least before Hurricane Harvey, I think there wasn't any political will to even consider climate change as a reality to a large extent. After Harvey, it's still not called climate change, but at least the concept of needing to be resilient to weather events that haven't happened yet, that concept has gotten a lot more play and is a lot more people's attention. So we're doing something about the resilience of Texas to climate change, even if we're not calling it that.
Okay. You mentioned that investment that we made in wind energy, and then we're ready for another major investment. If you were going to suggest something, what do you think would be the best bang for the buck? Would it be geothermal or solar or what?
Well, solar is just now getting to the point of being, competitive with wind in a sense. So that, and Texas, especially Western Texas, has a lot of sunlight. And so that I think is the next major area of expansion for Texas.
Okay.
Um, yeah, geothermal is viable, at least not, not with, we don't have a lot of hot springs, but we have a lot of holes that have been dug into the ground where we have hot temperatures as a byproduct of our energy exploration. And it's possible to take advantage of that temperature difference. There hasn't been as much focus on that as on wind and solar, but there's technologically it's a possible source of green energy also that could be exploited.
Yeah. Well, that's interesting. We do have a lot of holes that we've dug in the ground, as you say. Be cool if we could take advantage of those, right?
Yeah, if not for that, then at least hopefully for carbon sequestration, because we're gonna have to be taking more out of the atmosphere than we put in by the end of the century if we're gonna hit any of the targets that have been set.
Okay, so you brought this up. This is coming, I think, to the coast soon, maybe a plant. So I want to go there. This carbon sequestration, sending it to the ground. Since you brought this up, can you explain how that might work and is it viable? I know we're going off script here, so if you don't want to answer this question, that's fine. But
Well,
yeah,
I mean, it's worked as proof of concept, and it's a matter of scaling now at this point. The well, it's a I mean, technologically, it's a matter of scaling. Practically, it's a matter of finding someone to pay somebody else to put carbon dioxide into the ground.
okay, yeah,
Right?
that's what.
That's inherently not an economically attractive industry. Hey, I'm going to
Right.
bury stuff that you don't think about.
Right. Yeah, where would the money come from? We've been discussing this recently. Who would pay for that? The government? Or
Well, ultimately, no matter who it is the people that ultimately pays for it. But it
taxpayers? Okay.
could come about through regulations, saying if you emit this much, you have to sequester this much, or it could come
Yeah.
about through a market in carbon credits where if you've got a cheap way of doing it, you can make money off of it that way by offsetting the emissions that from an industry that isn't able to cut back very easily.
Okay.
Those are the main ways of it happening. It's not going to happen through donations, I can tell you.
Yeah. Imagine.
Just problem just too big for that.
Yeah, that's a huge problem. Well, is there any good news on the climate front? A lot of it's a little scary, but are you seeing some positive impacts from particular programs, or are you hopeful about certain changes that might bring big benefits?
Well, we keep beating the forecast in terms of fraction of electricity coming from non-fossil fuel sources.
That's good.
And that'll continue to be good news until the forecasters wise up and start becoming more optimistic, in which case we'll stop beating the forecast, but we'll still be on an upward trend at least. In terms of climate change itself, it's often presented as all extremes are becoming worse, but that's not really true. The cold weather is becoming less common and less intense in Texas. Snow is becoming less frequent. And based on the migratory patterns of retirees, people seem to still prefer to live in warm places rather than cold places. So
Yeah.
at least that's a good thing.
Yeah, that's true. That's a good point.
So we talked a little bit about carbon footprints and renewable energy with solar and wind talk. Do you have a sense for what things are really helping? Like public transport, reducing, reusing, recycling, these renewable energy sources. Are these really cutting down on carbon emissions? And if so, what would be your top 3 things that people could change, and that maybe at a personal level and maybe sort of at a population level?
Well, I mean, that's a tough one because um, there's probably only about 50 things that need changing.
That's an easy those are easy fixes, right?
So, the obvious, the biggest one as far as climate goes is get coal use down as quickly as possible, as much as possible. And we've succeeded in doing that to a large extent in in Texas, at least. Most of our energy is coming from natural gas, which is cleaner than coal, but then that becomes the next step. Okay, after we got rid of coal, we got to get rid of the natural gas. Um, uh, but to really do this effectively, you've got to have everybody on board. And so if you're going to say, okay, we're going to get rid of coal, then you got to say, okay, what are we going to do for the coal miners?
Yeah.
What are we going to do for the people who are hurt by that? Because you don't want to hurt a small fraction of the population today in order to benefit future generations. That's not really fair unless they're volunteering for that sort of sacrifice.
Right.
So we haven't, we the impact of climate mitigation actions on society hasn't really been reckoned with, not just within the United States, but also with respect to impacts in southern hemisphere or tropical countries where in the northern hemisphere that's been emitting carbon is driving the climate change, and other countries have to somehow deal with it. And it's just a big challenge to do that in a way that people would get on board with. And frankly, I'm kind of pessimistic that it's going to happen. I think we're just people are going to end up suffering because of climate change, and because they're somewhere out there, we're not really going to be able to deal with it effectively.
Is there anything in day-to-day life? I know those personal changes are really hard to make, but are there any small things that people can, shift on their day-to-day life that at least could reduce their personal carbon footprint, within reason? People have to drive to work, but, maybe taking public transport if it's available, or, does recycling really have an effect? I think a lot of people always wonder, like, is what I do actually helping? And maybe some reassurance there.
Yeah, well, recycling doesn't affect climate change very much, but definitely affects waste products and landfills and resources. So it's a good thing there, as long as what you're putting in the recycling bin actually gets recycled.
Right.
Which is important at both ends. You put the right stuff in, and it has to be economically viable to recycle it. Of course, yeah, people have to get to work. Although some people discovered during the pandemic that they were not quote unquote essential employees, and consequently could work from home.
Right. That's a realization for many of us, I think.
Right.
That's right. And for some reason, the more essential you were, the less you were paid. I still don't know how that works.
Yeah, scratching my head on that one too.
But you can avoid luxury travel potentially. The trips that aren't needed, or airline flights and so forth, tend to be pretty big carbon emitters. Also, food choices matter a lot. Greater amount of plant and fewer amounts of animals in their food means both fewer carbon emissions and less water use, and more land available for solar and wind to boot. So those three good things simultaneously.
That's great. Great advice. So climate change is sometimes the gloom and doom and very serious topic, but one of the things we like to ask our guests is about a biology blunder. So this is something that, when you were doing your work, everything went wrong that could, or something major went wrong that could, hopefully not too serious, but usually in a funny way. And so we just wanted to ask if you had any fun stories to share about your work with climate change.
Well, usually if something's going wrong in my work, it's because I'm trying to write this program that's just simply it's generating an error, and I can't figure out why. But falling asleep and waking up usually solves the problem somehow. But that's common in a lot of circumstances. I get somewhat more interesting problems when I'm doing outreach talks. Like, I don't know, somehow I'm an expert on everything. Fortunately, it hasn't happened to me in the past couple years, but I used to have people coming up after my talks on climate change, saying, "Okay, so tell me about those chemtrails. What's going on with those?" and I, if I tell people nothing, then I'm part of the conspiracy.
No.
So there's no real good answer to those circumstances. So I just say, well, a lot of, leave it at that.
Oh, man.
Super scientific answer there. Yeah.
You gotta speak
Better
a
than
language
no
people
answer.
understand.
That's about my
That's
knowledge
funny.
of chemtrails, so I would have taken it.
Right. Well, and interestingly, we were just talking about how what you said at first, how a nap can totally reset your brain and your creativity sometimes. So maybe there's something to that, falling asleep while you're trying to figure something out. And then when you wake up, there it is.
Well, you're also using fewer resources when you're asleep, so that could be another climate change solution.
There
Go
you
take a nap.
go. There you go.
Napping is always good for the
Naps.
environment.
Oh my gosh.
I love that. That's a new hashtag for Twitter.
Exactly. Nap if you love Mother Earth. Oh my gosh. That's so many nice hashtags there.
Oh, yeah.
Okay. Well, is there anything else that you'd like to share with our listeners?
No, I don't think so.
Okay. Thank you so much for your time. I've learned a lot.
I have too. This has been really great. We really appreciate you coming on the show.
Well, cool. Yeah, my pleasure.
Very interesting. Well, thank you so much. And remember, everybody, don't feed the wildlife. A Talk on the Wild Side is a production of the Cesar Claiborne Wildlife Research Institute of Texas A&M University, Kingsville. Funding for this project is provided by the Harvey Wild Sportsman Conservationist Award by the Rotary Club of Corpus Christi. Podcast artwork is created by the talented Gabby Olivas, and editing is conducted by Andrew Lowry.